everyone, welcome to my channel. Today let's talk about third category of questions under logarithmic differentiation method. If there is an equal sign in between two functions, it falls under third category. Let's try one problem. So here what we have to do means we need to find the first derivative of the given function cos x to the power of y, which is equal to cos y to the power of x. So here we know that we need to apply logarithmic differentiation method. Y means the base is a function as well as power is also a function. So we are going to apply that technique. Whenever we come across these kind of questions, we have to straight away take our log on both the sides. So log of cos x to the power of y, log of cos y on the whole power is x. We know that power comes in front. So we'll bring down the power in front and this becomes y times log of cos x and here x times log of cos y. So now what we are going to do means we are going to take the first derivative on both the sides. So here on our left hand side we'll consider product rule because the two functions are in the product form, so we can go for that. So our product rule says whenever the function is in the product form, it says that we can keep the first function as it is, derivative of the second function plus second function as it is, derivative of the first function. So we'll apply that technique now. So here we are going to assume u to be y and v to be log of cos x. So the derivative of our y is nothing but dy over dx and the derivative of the above function log of cos x has been given. That means a function of function has been provided to us. So we are going to apply chain rule. So first we will be taking the derivative for the outside function, which is log. So that is simply 1 over cos x, and then we will be taking the derivative for the inside function, which is minus sin x. Derivative of cos x is negative sin x. So altogether we are having negative tan x. So here on our left hand side we are going to write down the product rule uv dash. So y times negative tan x, so I am writing the negative sign front, plus vu dash, so log of cos x times u dash is dy over dx. So we have found the derivative for the left hand side perfectly. Now we need to again consider product rule for our right hand side. So here also product rule only. So for the sake of assuming, we can consider as fg. So we'll assume as f to be x. So derivative of x to be 1 and g to be log of cos y. So here g function is actually a function of function. So what we can do means we can apply our chain rule. So first we are going to find the derivative of the outside function, which is log. So that is simply 1 over cos y. And then we are finding the derivative of the inside function, which is cos y. Derivative of cos y is negative sin y. So negative sin y over cos y is negative tan y. So we are going to apply the product rule as it is. So here it would be fg dash plus gf dash. So we'll apply this pattern over here on our right hand side. So f times g dash minus x times tan y. We are writing the negative sign front. So that becomes negative x times tan y plus g times f dash, which is nothing but log of cos y times y. So log of cos y times 1 we are getting as log of cos y simply. So now what we can do means we can combine our dy over dx on one side. Here I want to remind you one thing. We have found with respect to sine over cos has given us minus tan y. But again inside function is y. So that would give us dy over dx. Outside function is log. For that we found the derivative which is 1 over cos y. With respect to cos y, while we are finding the derivative, we got negative sine y. Again we are looking into the inside function which is y. For that if we are taking derivative, that is dy over dx. So basically here we should interpret as dy over dx. So please remember everyone, y is there as the inside function means we need to again consider that for differentiation. So now we are going to combine our dy over dx on one side. So here on the left hand side log of cos x is there, and then right hand side minus x tan y is there. If we bring it on our left hand side, if we move it on the other side, becomes plus x tan y. On the right hand side we are going to write down the remaining terms. So log of cos y is there as it is we are writing, and then we are bringing this negative y tan x on the other side. Now here we have got dy over dx times the function. So that function, the sum of two terms, can be moved on to the other side as the denominator. So it becomes, we are going to write this as the numerator, log of cos y plus y times tan x over, this comes down on the other side, log of cos x plus x tan y. This is our required answer. If you didn't watch part 1 and part 2, it has been given in the description box below. Kindly go through the video so that you'll get the basic idea behind this concept. If you like this video, subscribe to my channel. Thanks for watching. Until next time.